Hello everybody, welcome back. In today's topic, we'll be discussing about stack data structure in Java. So what is a stack? A stack in Java is a linear data structure and it follows last in first out principle. In short, LIFO principle, meaning the last element added is the first one to be removed. Stack data structure is commonly used for tasks like expression evaluation, syntax parsing, and maintaining history. One of the very common example of stack data structures usage in a real world or the real day-to-day lifetime will be an example of browser history. Here is a diagrammatical representation of a stack data structure. Consider a stack as a container, and a container consists of tennis balls, correct? When you run the push method, it will add that tennis ball to the top of the stack. And when you run the pop method, it will remove the last entered or last added element from the stack. Here we can see A, B, and C is added and C is at the top of the stack. With the help of push method, C is added to the stack, right? And with the help of pop method, the top element, which is C, is removed from the stack. It's a very simple data structure used in many applications. Now let's study the characteristics of a stack. Stack consists of a push method which adds an element to the top of the stack. It also consists of pop method which removes and returns the top item from the stack. A peek method is used to retrieve the top element from the stack, but it does not remove the stack. And additionally, there is an isEmpty method which checks if the stack is empty. Now let's move back to IntelliJ to my screen and we'll see how the stack data structure is used. I'll create a package name DSA and create a class name with stack example, right? Now let's go ahead and create our main method. The stack data structure is present under java.util package and it accepts the generic data type. Let's import stack data structure from java.util package. The generic type will be an integer type and we are going to stack a list or a linear list of integer numbers. Let me give this name as stack and let's initialize the stack class. First, we will push the elements to the stack. Stack dot push 13, stack dot push 14, stack dot push 16. Right. Let me add a new comment. Here we will pick the top element. Pick at the top element. This is our print message as the top element in this key in this stack is stack.peak method. So basically this peak method will return us the top element of the stack. Now we'll pop the top element. Let's give it a popped element in this stack will be stack.pop method, and also let's invoke the isEmpty method which will let us know if the stack is empty or not. Is empty. right? Is stack empty, we'll run stack.empty method, right? Now let's run this method, right? So our stack example ran successfully without any errors, and let's now analyze the console log messages. The first system printout message, we can see at line number 17 we invoke the peek method. The peek method is basically used for printing or knowing the first or the top element of the stack, but it does not remove the element. So our console message shows the top element in this stack is 16, right? Because stack is a linear data structure, and at the line number 12 to 14 we issued three push statements, so 13, 14 and 16. So 16 was stacked on top of 14 and 14 was stacked on top of 13. Thus 16 is the top element and the peek method returns the same result, right? Then we did a pop method. In order to remove any element from the stack, we can issue pop method. The pop element in the stack, the print message suggests the popped element from the stack was line 16. Finally, we check if this stack is empty or not. Even after popping the first element, we still have 13 and 14 part of the stack, hence our stack empty method returns false. Even we can print the top element of stack after the pop and see that the top element now gets updated to 14. Let's run it. So we can see after we popped the 16th or the top element, the next subsequent element 14 became the top element. So this is how we use stack data structure in Java. Now let's understand what are the use case of it and answer few questions around concurrency. So these are some of the characteristics of stack which we looked before. Now the most common thing to know is the stack data structure concurrent? The answer is no. Stack class is considered legacy and does not synchronize for concurrent use. So if you want to do concurrency and use stack operations with concurrency, its better approach is to use DQ interface. Now let's understand what are the use cases of stack data structure in Java. It is used for backtracing algorithms, example maze solvings. It is also used for expression evaluation and syntax checking. It is also used in recursive function calls. In fact, stack data structure is why we can do debugging in most of the IntelliJ IDEs, and this helps us to work with recursion and many recursive programming. That's it for now. Thanks for watching this video. In the next video, we will code out our own stack class with our own push, pop and peek method implementation.